Alright, guys, so let's go ahead and get started on example 2 here. Now, in example 2, if you take a look at the rational expression, we do have rational expressions that have a degree higher than 2. So there's a few things that we need to do different here, especially on the top one, so it could just be simpler for us to solve. So that first thing that we need to do here is substitution. Now, when we do substitution, we're basically choosing another variable to represent, for example, our degree x to the fourth or a smaller degree. So for example, in this case, I can say that a is going to represent my x squared. And if I do that, then that's basically telling me that if I rewrite x to the fourth, it could be expressed as x squared to the second power, which means that wherever I see the x squared, I'll go ahead and replace it with the a. So then in this case, we have a squared plus an 8a plus 7. And from here, as you guys can see, I also replaced the x squared with an a. And I'm basically looking for two factors of 7 that multiply, obviously, to 7, but also add up to 8. And in this case, those would be 7 and 1. So then we have a plus 7 times a plus 1. And all we're doing from here is that we're going to go ahead and just substitute back. So we expressed it as a, but our goal is to express it back to x. So instead of having an a, I'll go ahead and substitute that with the x squared. So we have x squared plus 7 times x squared plus 1. So this is equals, and I'll go ahead and put it as my numerator. X squared plus 7, x squared plus 1. So moving on from here, the bottom one, we can actually factor out a 3x. So we'll go ahead and do that. We have a 3x in front. And inside we have x to the fourth minus 1. And once again, we have higher degree. And I'm going to go ahead and use the same substitution I used here. So I'll go ahead and do that in green. And we have x to the fourth minus 1 basically equals a squared minus 1. And if you guys recall, a squared minus 1, this would be a difference of squares. So then this basically factors to a plus a 1 and a minus a 1. And from here, we're just going to go ahead and substitute it back with the x. So since a is x squared, we have x squared plus 1 and x squared minus 1. So let's go ahead and rewrite this. So we have equals, and we have our x squared plus 7 times x squared plus 1 all over, and we still have that 3x in front. X squared plus 1 and x squared minus 1. So from here, you guys can actually see which ones are going to be canceling out. We have x squared plus 1 as the common factor, so those are going to be canceling. So let me go ahead and just rewrite it. And that equals, I'm going to write it in the same color. X squared, or actually I don't need parentheses. X squared plus 7 on top, and on the bottom we have 3x times x squared minus 1. Now here we're partially done because we still need to identify what restrictions we need to place for our x values. So then from here, when we were looking at restrictions last week, we were basically making the expressions in the domain equal to 0, or in the denominator, I'm sorry. So then we have 3x equal to 0, and we have x squared, this is or, minus 1 equal to 0. So in this case, x equals 0, and x would equal a plus or minus 1. So basically the restrictions for x in this case would be when x is 0, so x cannot equal 0, or x cannot equal a plus or minus 1. And that would basically be our final answer.